reduce the beacon interval and start sending more beacons, it becomes slightly harder to spoof. What if we start sending twice as many beacons per second, 4 times as many than normal? Then yeah, you can actually tell that something bad is going on because you actually see a lot of jitter. But then, of course, you can increase your beaconing. You can shrink your beaconing interval even further. But then, of course, your network will be all beacons. That's very useful. On the other hand, if you reduce your beacon rate, well, this is where spoofing becomes much, much simpler. Okay, then. So, for conclusions, timestamp measurements are really nice and exciting. It's just there are a number of really interesting papers out there, starting with the classic by Conobroy de Claffey, and continuing to that paper that we slightly adjusted the claim of, that it's a great paper and it's a great piece of work. And you know, even if we were scooped, we were happy that the idea has been put out there. Except, of course, software scheduled injection is not the best that one can do. In fact, if you look into the card, and this is actually what I learned at Shmooncon and at TourCon, is that you really have to know your card. You really have to know your driver. You really have to, and it's great because you can meet all the people who are experts in this, which we're not. And you know, ask them nicely, and they might actually be able to tell you. But you've got to know your card, and if you know your card, you can spoof those things really, really well because the card itself does most of the work for you. It's already helping you a lot. So, nevertheless, if you're paranoid about who you connect to or about what sort of access points are on your network, and you can do a lot of sniffing, which we actually can on Darknet because we have about 200 wireless monitors spread out through the campus, then asking a device, what's the time? What's the time? What's the time? What's the time? Is a good prelude to a closer association. And a good way of, and listening is a good way of finding out what this device might be as opposed to what it's claiming it is. And finally, unfortunately, AP beacon timestamps appear to be spoofable. So if you're building a product based on that, you have to be very careful as to what you measure. A simple line fitting technique would not work. You'll have to watch out for jitter, and maybe, just maybe, you'll have to do something else. And we should all try harder. And of course, you know, we'll take a look at, we'll be happy to take a look at that once you're done putting in the hard work of developing it. And we're going to post the slides and the patch for what it is. And this is a picture that I was looking for to conclude with the title, "What's the Time, Please?" And this is what Flickr came back with. So apparently this emu wants to associate, but is careful who he deals with. And there is another one out there, I think, doing the same. So, you know, it's looking in, looking at the dashboard timer. And, is that really this car that I want to be dealing with? Okay. With that, I'll take your questions.
I don't have a question so much as a point. I think that you can get rid of the part of the jitter issues by adding a second register into the driver and having it increment the TSF timestamp by a certain number of milliseconds per.
I'd love to talk about this, right? Yeah, Okay. So the point is that we could get rid of the jitter by using another register. Now, from what we found out about the card, we could not find, I mean, the register that was there was worked on by firmware and was consulted by firmware. And so we have not found another register that would, you know, it's actually two registers, two 32-bit registers, one 64-bit register. We have not found a way to do this, but I would definitely love to know how. So please, please, please.
Yes, the second part of that is that you're updating that register, but looking at the jitter on the order of 2 microseconds per beacon, that is right around the range of what frequency it's running at. So I would say that if you can stick to the same register, but make that code run in real time, because it appears that there might be 10 clocks being used as a subroutine sometimes, not all the time, after that register is being dumped into the RF.
Now, I fear that we would need to deal with firmware at this level, and we do not have that. I mean, we do not have that capability. We would love to. Now, what we tried to do was merely with the driver, and we think of this as a cheap way. I mean, if you can think that ubiquity is cheap, well, I can afford it, right? But yeah, like I said, I'd love to talk about this. Any more questions? Yes, please.
What about the beacon rate that you're changing? Can you use that as, I mean, you match clock speed, but now the beacon rate is different. Is that something you can continue to fingerprint with?
So it doesn't really matter for the clock skew how many beacons you receive. It's just the accuracy of how you can spoof. So
If I'm the client trying to determine which one I want to associate with, can I use the beacon rate as part of my fingerprint?
well, yes. So we actually never saw a beacon interval different from the default. But certainly, if you find that somebody is beaconing at a rate that's not exactly what you expect from your regular infrastructure AP, that in itself is a dead giveaway. There is a bit of an issue with that, though, because the beacon queue is the lower priority queue, and so sometimes beacons are skipped. So if you look at like inter-beacon intervals, that's not a very good fingerprinting technique we found out. But if you really see an AP beaconing at something other than an accepted and normal infrastructure beaconing rate, yeah.
I was actually thinking your technique, where it decreases jitter, you change the beacon rate.
Well, we'd be giving, yes. So we'd probably be able to fake that better if we changed our beaconing interval. On the other hand, we'd be giving ourselves away by the very fact that we don't send 10 beacons per second, but rather a different number on average.
So when you looked at the vendors' products that you looked at, nobody's doing any kind of dynamic beacon interval change? It's all manual?
We have not, what we've seen so far, and we haven't seen much, has been it's not one of those settings that people think much about. And it's almost always in what we've seen we have a Naruba infrastructure. We used to have a Cisco infrastructure. We still have a Cisco infrastructure in an affiliated medical school. And it seemed to us that no one is actually doing anything much with the beacon interval.
So the variable's exposed to the operator, but nobody's really paying attention.
Yeah, not that we noticed, not that we know of. The original paper proposed this as a widths primitive to look out for, and our concentration has been different. Our concentration has been, well, if you're really paranoid, what can you do without your driver being changed to something completely different and being